Good day everyone and welcome to Modez Tutorials YouTube channel. Today we'll be discussing qualitative and quantitative analysis on chemistry practicals. Now this particular topic, you cannot escape it in chemistry practical for WAEC. Yes, West African Examination Council. So we will be dismantling everything concerning this topic in two videos. This is the part 1. Make sure you watch to the end and also make sure you watch the part 2 when it is uploaded. Let's dive right into it. So we will start with quantitative analysis, which also means measurements. Quantitative analysis, measurement analysis. And under quantitative analysis, we can talk about volumetric analysis, which is your acid-base titration or titration. Do you get it? Now, since you already know that quantitative analysis has to do with measurements, and you already know that under measurements, what you should expect more is titration. Let's just talk about titration. Titration basically means using a practical method to find the concentration of an unknown solution. Do you get it? That is what titration is. Usually, they give you the concentration of A and tell you to find the concentration of B. Do you get it? That's how it is. Now, let's now talk about, let me just describe, since I don't have the apparatus here, I will just describe quickly how you should titrate or how you can titrate. I'll use diagrams. Then after that, we are going to treat a proper WAEC standard question on this topic, and I will dismantle everything. So make sure you stick to the end of this video so you don't miss anything. Alright, so let's dive into how titration is done with just diagrams, because I don't have the apparatus here. So first of all, this is your conical flask. I'll tell you the function of each of them. This is your pipette. This conical flask. Then this is your retort stand. With your burette here. This is your burette. Do you get it? Now, first of all, the function of this pipette is to find a fixed volume. Is to what? To get the fixed volume of base. So most of the time in Nigeria, or usually in Nigeria, we usually use 25 cm cube, but sometimes it can be 20 cm cube also. Do you get it? Well, I'm sure in your school, the one you use was 25 cm cube. Do you get it? So this is usually constant. This is usually fixed. The volume of the base. This is the volume of the base. This determines the volume of the base. Do you get it? So this is where you put the base. You know that moment where you have, they will tell you to use your mouth to suck. You know, in Nigerian practical school, when you as someone that went to a Nigerian school, that's how we did it. You just try. You have to be very, very careful, and you have to make sure that the meniscus is directly under that line. Do you get it? It's showing directly under that line, directly, like very, very close, so that it will be on that dot. Do you get it? So that you get the exact fixed volume of the 25 cm cube. Don't forget, the pipette is always 25 cm cube most of the time. Sometimes it is 20 cm cube also. So this is where you put the volume of the base. Now, after you have gotten the fixed volume of the base from the pipette, you put it here. Do you get it? Inside the what? The conical flask. So in the conical flask, you already have the base here, right? Exactly. So let's leave that separately. Now let me explain the burette and its function. I already told you that for the pipette, it contains the volume of the base, right? Now the burette contains the acid, and it is what you use to determine the volume of the acid used. Don't forget, the major aim of titration is to get the endpoints and also the what? Volume of acid used. And to get this volume of acid used accurately, the endpoint has to be what? Accurate also. Now, you fill in your acid into the burette. The calibration is usually from 0, and always make sure that your readings should be in at least 2 decimal places, WAEC standard. If, for example, your reading is 6.0, don't write 6.0, should be 16.00 rather, then cm cube. Do you get it? And always make sure that you write the unit. I'm still going to explain these things further. Just saying it now. Do you get it? Now, you put in your acid, right? Now, in order to get the end points, which is where the equations will be balanced, the reaction between the acid and the base, the point where it is going to react together and give you a balanced product, that is what you use to determine. Now if you do this thing without an indicator, the reaction will occur and it will be balanced, or it might even pass where it's supposed to reach. Do you get it? But you will not know if you do not use the indicator. That is why an indicator is very, very important. Now let's say the indicator in this case is phenolphthalein. Before you start, you know, releasing these burettes, the acid in these burettes into the base in the conical flask, you need to make sure that the indicator is already inside here. Then you mix it together very, very well. Then what do you do next? You bring this conical flask under the burette, then you shake it, while at the same time releasing. There is a small adjust here. Right? This is called the burette tip, or no, burette adjust. Let me just call it burette adjust. I don't really know what it's called, but this particular adjust here is what you use to carefully release this acid into the conical flask. So that you will not release too much of it, so that you will get the accurate end point. Now the accurate end point is the moment where the colorless phenolphthalein in that base changes to pink. Immediately it changes to pink, you have gotten your end point. So let's say, for example, it changes to pink at 9.10 cm cube. You record it as what? Initial will be what? 0.00, and final will be what? Final will be 9.10. This is how you record it. So get initial, final, so that when you are calculating, you get final minus initial. Do you get it? We are still going to come to a practical aspect of it. Calculation aspect of it. I'm just explaining it. So now that you have gotten the endpoints, you have successfully what? Done your titration. Now there's something I need to talk about before we move into actual calculations. Now, when you want to do your titration table, always make sure that you do it this way. At least have a rough titer. A rough titer. Don't mind my handwriting. Then your first titer. Then second titer. All in cm cube, right? All in cm cube. Everything is in cm cube. Then your burette reading in cm cube also. Do you get it? Then your final burette reading will be here. Initial burette reading will be here. Now you can use this particular, your first one. Now there's something you need to take notes. Now, when I was actually learning this particular topic, I thought that your rough titer is your first titer. No, your rough titer is not your first titer. Your rough titer can even be the last one. Now, rough titer is the one that is not very, very close. Let's say after you have done 3 titrations, write them out. Let's say your first titration, you got, let's say your first titration, maybe after your final minus initial, you got, in the first one you get 9.10. The second one you got 9.15. Then in the third one, after your final minus initial, you got 9.30. Which will be your rough? Of course, this should be your rough, because the distance between this and this is already too much. Most of the time, it should not be, the difference between your titer values, your first and second titer values, should not be more than plus or minus 0.04. So even this is too much. So let's do something like this. Do you get it? So that at the end of the day, when you get average of this, it is still close to this, and it is still close to this at the same time. And this should be your what? Your rough titer. Now let's go into a proper calculation. All right, this is a question based on WAEC standard. So let's just go through the question first. A is a solution containing 0.05 mole per dm cube of H2SO4, which is tetraoxosulfate 6 acid. Okay. Then B is the solution of anhydrous Na2CO3, which is what? Sodium trioxocarbonate 4, containing 5.3 gram in 1 dm cube of solution. Now, we are not titrating here because we cannot do any titration, and if you want to get any endpoint, you have to manipulate. That is why I had to bring this kind of question. So this is more like an alternative to practical, but when I'm doing the tables, I will also be explaining some certain things. So make sure you pay attention very, very well. Now, first of all, this is something where I can ask. Number one, write a balanced equation for the reaction. First of all, they told you that this is a reaction between what? H2SO4 and what? Sodium trioxocarbonate 4. So first of all, let's try to balance the equation. Balancing of chemical reaction. This is one of SS1 topic, right? SS1 topic, so H2SO4 plus Na2CA CO3. First of all, whenever there is a carbonate, whenever an acid is reacting with a carbonate, it will always give you what? Carbon 4 oxide and water. Carbon 4 oxide and water. Take note, this is a general something. Whenever you see an acid, weak or strong, reacting with any sort of any carbonate, as far as you see CO3 there, what you are going to most likely get, especially salt of sodium, potassium and ammonium, you are going to get carbon 4 oxide and water. That one is sure. So what do? First of all, the salt of what? You get what? Sodium tetraoxosulfate 6 plus carbon 4 oxide plus water. So let's check, is this equation balanced? SO4, Na2, 0. Okay, the equation is balanced actually. The equation is balanced. Number of mole of everything here is the same thing as number of mole of everything here. Do you get it? Everything is balanced. Hydrogen is 2 here, hydrogen is 2 here. Oxygen is 4 plus 3, 7. Oxygen is 4 plus 2 plus 1, 7. Sulfur is what? Sulfur is 1. Right? Sulfur is 1 here also. There's nothing else here. So this is a balanced equation. So get exactly. That's why it's very, very important to know all those rules. All sort of triazocarbonate 4, all sort of triazonitrate 5, all those things, their reactions. Go and know what their products. Very, very important. Now, for the second question, it says that state the suitable indicator. State the suitable indicator for this titration and its color change and the end of the reaction. Now, first of all, you need to know that this is a strong acid, right? Tetraoxosulfate 6 acid is a very strong acid. Exactly. Now, sodium trioxocarbonate 4 is a weak base. A weak base does not completely ionize, right? It does not completely ionize. It is weak. It is not oxide or hydroxide. And even it is an oxide of sodium, it is going to be a very strong base. And even it is an hydroxide of sodium also, it would have been a very strong base. But because it is more or less a salt of sodium, it is a weak base. Do you get it? So when you are titrating a strong acid and a weak base, the best indicator to use is what? Methyl orange. Methyl orange, and it is kind of yellowish at first or orangish. Then at the end product you get color pink. At the end points, color changes to pink. So there's still more questions, but because of there's no space, I hope you can see everything I wrote clearly. This is methyl orange, and at the end point the color changes to what? To pink. That is the answer for this question. Let's move. Now, continuation of this particular question. Now, This is the third part of the question. We talked about indicator and the balancing of the equation before, right? So now this time around it is something different. They said what? The table of results if 25 cm cube of solution B was pipetted and average titer value, volume of acid obtained was 25 cm cube. Show how to record this in a standard titration table. Just show how to record it in a standard titration table. Now remember that I told you that in your WAEC practical you are not going to be doing this. You will not see this. They might tell you to show it in a standard titration table, yes, because of course you need to do it. But they are not going to give you the volume of acid used. You will be the one to look for it yourself. As I said before, the only reason why I'm using this kind of question is because I don't have all those apparatus and everything that is needed for me to do the titration for you so you can see it. So the best bet is to use an alternative to practical, which is what I'm doing right now. Do you get it? So don't forget that this is how you tabulate this. This is how you represent it in a table. This is the first thing you should know. Now look at everything that I did here. You will notice that what? Here we have what? Burette readings. Now under Burette readings, there's final reading, there's initial reading. Then there's what? Volume of acid used. This should be how your table should be like if you want to get your full mark. If you do your table like this alone, you are going to get, with all these units there, you are going to get half mark for this. Yes, this is WAEC standard. Do you get it? Now, don't forget that you have rough titer value, you have the first titer value, and you have the second titer value. And what we are trying to do is to manipulate the readings up to this point. So in the rough titer, I can say the initial reading of the rough titer was 0.00. Don't forget, it must always be in 2 decimal places. Don't forget, 2 decimal places. It must be like this or like this. That's 2 decimal places. Hope you are getting it. Now, so for the final readings, this can, since this is rough titer, I can just use this as 26.50 or just 26 point. It is a rough titer, so since you put rough titer there, WAEC is not going to even look at it at all. They will understand. Do you get it? So you can just do this. This is your rough titer. But then, your first titer will be what? Don't forget, we have to manipulate it in a way that we have to get this exact 25.00. I'm going to explain something later, but you understand now. Let me write this first. So now, this is the first titer, Abi, and you already got 25.00 here. Now, for the second titer, we can now say the initial was 25.00, then the final is now what? This is basic manipulation of table. Now, in my own WAEC practical exam, after I did my first titration and I got it, and I got that point, I think it was 16 point something, then I can't remember. But I did not even bother to do second titer, third titer, because I know it was going to take time. Do you get it? What I did was I just manipulated the reading for the other ones, and I did my average volume of acid used, and I got my answer, and I moved on. Do you get it? But you don't have to be like me. But this is a way you can also manipulate. Once you get your first answer, and you see that okay, you did the first one well, it's not as if you rushed or you can just do another one after that. Then you can now look at it and manipulate the remaining one. You don't need to waste your time to do it over and over and over again. And don't forget that this is only this way. It is only this way because we have to get this 25. And there's no way you can get exactly 25 unless you do 25 plus 25 over 2, which you have to give you 25 also. That is the reason why it is like this. Now, if in another case whereby you are doing your own normal titration, you were not given this volume, right? And in your own first, maybe your rough titer, you got 25.20. Then you now did another one, you now got 25.50. This is non-concordant. This is not concordant. The difference is too much. The difference is what? It is too much. Right? So you have to what? You have to make sure that it is nothing less than, don't forget what I told you, plus or minus 0.05. This is what you should use. Oh. This is what you should use. If you have something like this, 25.20, and you have something like this, 25.50 as another title value. Now, when you are at this stage, you cannot manipulate results. You have to do another titration again to confirm and try to get something that is very, very close to this. At least something like this, 25.25. Do you get it? Can you see how close they are? This can easily get you more mark than when you bring in this, the gap is going to be too much. And even if you are not close, I think even if you are not close to the real volume of acid that they have, as far as your own values are non-concordant, you can still get mark for that. So make sure you take note of this. So now you have successfully represented this as a table. This is just what we need to do for this particular question. Now, normally, let's say you did your own titration. What you now have to do here is you have to further by saying that what average volume of acid used. So the formula is first titer plus second titer over 2. So first titer is 25 plus 25 over 2, which is equals to 50 over 2, which is equal to what? 25.00 cm cube. Please and please, when you are doing your this is the reason. You see this cm cube. This is the reason why I did this average volume of acid used. Do you get it? So that when you are doing your calculation after your titration, your chemistry practical is very, very close. So all these things are something you need to take note of. All these simple mistakes because of pressure, because of rushing, don't make them. You have to calm down. That's why you have to know them now before you enter the exam hall. Do you get it? So yes, let's move on to the next question now. This is the main. This is where WAEC will even want to put in more energy. Watch it. Question of the previous question. Calculate the concentration of B in mole per dm cube. Now, concentration in mole per dm cube is equal to what? Gram per dm cube. That's concentration in gram per dm cube over molar mass. Please take note of this formula. It's a very popular one. You will need to know it. Now, in this particular question, you will notice that they gave us what? That B is a solution of anhydrous sodium triisocarbonate 4 containing 5.30 gram in 1 dm cube of a solution, which is automatically telling you that the concentration of this solution in gram per dm cube is what? 5.30 gram per dm cube. Now, how do we get the molar mass of B? Don't forget that B is what? Na2CO3. Now, to get the molar mass, you get the molar mass of each of them. They add everything together. Now, molar mass of sodium is what? 23. 23 times 2, right? Plus molar mass of carbon 12, right? Then molar mass of oxygen, 16 times what? 3. You know the reason why I'm multiplying it, right? Sodium has this 2 here. So you multiply it. Oxygen too carries this 3 here. So you multiply it. Then when you add everything together, you get what? 106 gram per mole. Then when you bring this into this, 106 gram per mole. So yeah, basically, yes, if the gram cancels the gram, then you have mole per dm cube. So whatever you get is going to be so let me quickly punch this in the calculator because I don't know what this gives. So all right, so this actually gives you what? I define because I know I put it somewhere. Yes. This gives you 0.05 in mole per dm cube. Let me write this very well here. 0.05 in mole per dm cube. This is your answer for this particular question, right? Now, for the next question, they said calculate the number of moles of acid in the average titer. Now, to calculate the number of moles, what is the formula you use? Don't forget that we know that the concentration of the acid is what? 0.05 mole per dm cube. Now, if you even look at it, the concentration of the acid and even the concentration of the base that we got that time is the same thing. And I'm thinking it's because they use the same volume. If you remember, the volume of base used was 25 and the volume of acid used too was 25. And the mole ratio is even 1:1. But the reason why I'm doing all these things is so that you can understand the concepts better. I don't have a proper practical question that I will have to titrate to give you the answer. That's why we are doing alternative to practical. So the concentration of acid here is 0.05 mole per dm cube, and the volume of acid is what? 25 cm cube. Now, in order to look for the number of mole, the formula is what? Number of mole of acid is equal to concentration of acid times volume of acid over 1000. Now, here you have what? 0.05 as the concentration times what? 25 over 1000. And this will give you what? When you punch your calculator, you get 0.00125 moles. Don't forget, it's the number of moles, not mole per dm cube. When it is concentration, it is, see, if it is concentration of the solution or concentration of an acid or a base, it is in mole per dm cube. If it is gram concentration or mass concentration, mass concentration, it is gram per dm cube. We are still on titration, and this is the final question that I've just written. If the salt, which is B, was hydrated and the mass concentration was 14.3 gram per dm cube, mass concentration is what? 14.3 gram per dm cube. Calculate the value of x. You wonder, we have this and we are looking for x, but they already gave us what? The mass concentration. Now, don't forget that with the mass concentration, you can get the what? The molar mass. And once you can get the molar mass, you can easily get x. Now, let me show you. Okay, we already know that the mass concentration is what? This. Now, don't forget that the molar concentration we got for B was the same thing as 0.05, which is the same thing as the acid. Do you get it? So, molar concentration is 0.05 mole per dm cube. Now, don't forget I told you that what you need to do is what? Get the molar mass. Once you can get the molar mass of this water of crystallization salt, you can easily what? Get the number of water of crystallization that it has. Now, how do we do that? To get the molar mass is equal to what? Mass concentration over molar concentration. So get, so 14.3 over 0.05, this should give you what? Molar mass is equal to 286 mole gram per mole. Please, gram per mole. Do you get it? Molar mass is gram per mole. This is gram per dm cube. And this is mole per dm cube. So this basically cancels this, giving you gram per mole. Do you get it? Don't forget, I told you that we have to equate this to this. Now, we already know this dot here in water of crystallization is the same thing as plus when you are calculating the entire molar mass. That's another trick. So now, we already know that Na2, oh sorry. We already know that what? Na2CO3 is also the same thing as 106 gram per mole, right? Now we just need to look for the what? The molar mass of XH2O, which should be what? X open bracket what? 2 plus 16. Do you get it? Which should be equal to what? X open bracket 18, which is equal to what? 18x. From chemistry to what? To linear equation. So since you have gotten this as this, let me erase this ASAP. Don't forget what I told you. You will now equate what? This equals this. What I'm trying to say is more like Na2CO3 H2O equals to what? 286 gram per mole. Do you get it? Now, according to what I told you, this will now be equals to what? 106 plus 18x, which should be equal to what? 286. Right? Right. So, you now have what? 18x will be equal to what? 286 minus 106. Basic mathematics. This one is moving to this side. Do you get it? Then 18x will be equal to what? Will be equal to what? 180. Therefore, x will be equal to what? When you divide through by 18, x will be equal to what? 10. That's not all. So, since x is equal to 10, it means that the water of crystallization here is what? NO2CO3 decahydrate. Now, if they say you should name the compound, this is what? Washing soda. Sodium triazocarbonate 4 decahydrate is the same thing as what? A washing soda. Now, we have successfully what? Completed a practical question. Make sure you practice past questions as much as you can. Although this video is going to help you a lot. In fact, the part 2 is going to drop very, very soon. And that is going to give you even more insights on qualitative analysis, even some things you did not know, or some things your secondary school teachers did not tell you about. So if you have any of your friends taking WAEC chemistry, share it to them. Do you understand? I'll see you guys next time. I remain Modez, founder of Modez Tutorials.